class, Dr. Barnes here. Let's take a look at this very simple question in Fourier transforms. Okay, so here we have x of t is equals to e exponent minus a mod t. Okay, so whenever we have x of t to be equals to e exponent minus a mod t, modulus of t, what it means is that the t will be what? Positive and then negative. So let's see when the t is positive and then when it is what? Negative. When the t is positive, then here we're going to have e minus what? at. When t is positive. When t is negative, then good what? Negative, negative. Okay, which will be what? Positive. So you're going to have e minus what? E into what? E exponent at. Okay, so here we know that the nature of this graph, this place is for when t is greater than what? 0. And this place is for when t is what? Less than what? 0. When we plot it, you will see. So here, this is the nature of this graph. Here is what? T. Here is what? X of what? X of t. So e exponent minus at will be something like this. So this is what? E exponent minus what? At. So you can see that here is what? 0. This place is running into what? Infinity. Here is running into what? Minus infinity. So you can see that this place, the graph is what? Greater than 0. T is greater than 0 at this place. And this one, e exponent 80, that the nature, here is 1. The nature of this graph is like this. Okay, so here e exponent what? 80. And here, what you can say is that t, okay, is less than what? 0. So if you have t here, then it's less than what? 0. Alright, so that will be the nature of this graph. So now, if you should put this one into the Fourier transform equation, then I'll have what? X of omega is equals to what? Here, minus infinity to what? Infinity. Okay, then I'll have what? X of what? T into what? E into minus j what? Omega what? T dt. Okay, so x of what? Omega is equals to here, let me say here omega minus what? Omega. Okay, xt of t. What is xt of t? Xt of t is simply e exponent what? Minus what? A mod what? Mod t. Okay, into what? E exponent minus what? J omega what? T dt, which is equals to what? Here minus what? Infinity. Here what? Infinity. Okay, so from what I have stated over here, okay, what I have done here, okay, and from what I have stated here, okay, so this one will actually be equals to e exponent, okay, I can say that e exponent minus what? At, and then e exponent what? 80, okay, or into what? E minus j omega what? T, the what? The t. Okay, so if I should actually split this, then I'm going to have e exponent x of omega is equals to, if you check this place, okay, if you check here, you can see that this is from what? Minus infinity to 0. So I can say that from minus infinity to what? 0. Okay, I have what? E exponent what? 80 into e minus j what? T. The what? The t. Okay, the t. And then what I'm going to have here is what? Plus here to what? 0 to So 0 to what? Infinity. I'm going to have e exponent minus what? At into e minus what? J omega what? T. The what? The t. Alright. So now what I'm going to have again is that I'm going to make it simplify it. Okay, so x of what? Omega is equals to what? Minus what? Infinity to what? 0. Okay, e exponent what? A minus what? J omega. Okay, into what? T, the t, plus or 0 to what? Infinity. Okay, e exponent minus a, okay, plus what? J omega into what? T, the what? The t. Alright, so that's what I'm going to have. So now here, if you do the integration, you're going to have 1 over a minus j omega, okay, into e exponent a minus j omega, okay, into what? T, okay, plus, and here the limits are minus what? Infinity and what? 0, plus what? 1 minus 1, okay, over what? A plus j omega into e minus a plus j what? Omega into what? T into t. Okay, into t. And here the limits are what? The limits are 0 and then what? Infinity. Okay, so now, okay, so now, when you put in your limits, what you're going to have is that if I put in minus infinity here, it will go to, no, always put in the upper limit first. So if I put in 0 here, I'll get what? 1. If I put minus infinity here, I'll get what? 0. That means that x of what? Omega is equals to 1 over what? A minus j what? Omega. Okay, times what? Times 1. Okay, because if I put 0 here, I'll get what? If t is 0, I'll get e exponent 0 is 1. And if t is minus infinity, e exponent minus infinity is what? 0. So I'll get what? 1. Okay, and then here, I'll come here. If I come here, if I put in infinity, it will what? Minus infinity. Minus infinity. E exponent minus infinity is what? E exponent minus infinity is 0. And if I put in what? 0, then it will what? E exponent what? 0 is 1. But because this 0 is lower limit, it will have what? A negative sign. So negative will be what? Positive. So I'll have 1, I'll have plus a plus what? J what? Omega. Okay, a plus j omega. Alright, so this will become what? My answer. And if you should add them, then you will have what? 2a over what? A squared plus what? Omega squared. Alright, so this is the answer you're going to get for this one. Okay, so now, when you have been able to derive the answer for this one, then what you can do again is to be able to do the magnitude spectrum. Okay, so magnitude spectrum, x of what? Omega versus what? Omega. Now here, x of omega, okay, modulus, okay, is equals to what? 2a over what? A squared plus what? Omega squared. Now this is omega, and this is what? X of what? Omega. Now let's say omega is 0. If omega is 0, then 2a over what? A squared. What will you get? You get 2 on a. Okay, so I'll get 2 on a. Now if omega is minus infinity, okay, let's say omega is what? Minus infinity. Omega is minus infinity. If omega is minus infinity squared, 2a divided by minus infinity squared, that will be what? 2a divided by what? Infinity. Okay, and then that will be 0, because if 2a people are, if infinity is going to divide 2a items, everybody will get 0. Now, if omega is infinity, so 2a over what? Infinity squared. If you have 2a items and infinity number of people are going to divide it, it will be 0. Okay, so now from here, you can just draw your what? Your frequency spectrum. Okay, from here you can just draw your frequency spectrum. So your frequency spectrum here is omega, and then here is what? Mod of what? X of W. Okay, so the highest number here is 0. The highest number here is 2 on A. So 2 on what? A. Okay, and then you have 0 here is minus what? Infinity. Minus infinity. And here is what? Infinity. So 0 into this one, you're going to get something like this. And then this one, you're going to get something like this. Okay, so that will be your phase, that will be your magnitude spectrum. Okay, this graph, it has no phase spectrum, because it has no what? Phase spectrum. Okay, because it has only real parts. Okay, so that'll be the end of this question. See you in the next class. Thank you so much.